Hey, boys and girls, welcome back to another day in online learning. Thursday. We only have today and tomorrow, hopefully, and then we have break, and then back to normal school, hopefully. At this point, you should know that we are opening the Google Meet, then opening up Desmos in today's lesson, which is dilation mini golf. Love mini golf. All right. So again, you're going to be pausing and fast forward, pausing and then doing the activities yourself throughout this lesson. But let's start off with the warm up. All right. It says, welcome to Dilation Mini Golf. Your goal is to get point B into the hole. So if we try that, we get point B into the hole. Then it says, discuss what you think scale factor of 4 means. Well, notice that point B is right here, or whatever that length is. And then when we hit, we end up with 1, 2, 3, 4 line segments instead of just one. So think about, we took one line segment and we multiplied it by 4 to get the ball to the hole. So round 1, it says point B will be dilated using C. So C here is the center of dilation. So that means the ball is going to go away from point C. Now, we have a scale factor of 2. So remember before, on the last page, we are going to go this distance times 2. So we're probably going to end up somewhere along here. So if I press try it, notice that I'm 2 line segments away from point C now. Now we want it to land in the hole. So think about this. Here, this distance would get me to the hole, but I'm going the opposite way. So I'm going to need C to be over here in order for me to get the ball in the hole. So let me drag this around. And it was somewhere around here. And I have found that I had one line segment that I multiplied by 2 to get to the hole. So all we're doing with this new word called scale factor is we are multiplying whatever we started with by that number to get a different length. Point B will be dilated using C as the center of dilation, with a scale factor of 4. So that means this line segment times 4. So 1, 2, 3, 4. So notice we have 1, 2, 3, 4. And it looks weird because we have 3 new line segments. Well, in total, we have 4, okay? So drag the center so that point B lands in each hole. Then celebrate and continue to the next screen. So you try that out right now. All right, I'm going to try this one myself. Ooh, I went a little far. All right, you all try this now on your screen. You should pause at this moment, and you are trying to make it into each of these holes. Once you make it into all those holes, return back to this video, and then continue. All right, so what is the scale factor? So point B was dilated using C as the center of dilation. So notice that right here is our first line segment. What is the scale factor to get B to the hole? Well, all we have to do is count. 1, 2, 3, 4, 5. So our scale factor is going to be a scale factor of 5. And explaining our thinking, I notice that there are 5 of the same line segments to get to the whole. All right, now we're in round 3. It says here's a different round where you can drag point B. So now we move point B around, and C is going to be the center, so we can't move C. So point B will be dilated using C as a center of dilation with a scale factor of 3. So notice that we're going to have 3 lines now, 3 line segments. So notice here I have 1, 2, 3. So the ball should end up somewhere right here on this end of the 3rd ring. All right, so that's a scale factor of 3. All right, so we're going to drag into each hole. Notice for this one, this hole was just like that example I just showed. So we have 1, 2, 3 to the 3rd ring. And we are in the hole. All right, so try that out with those. Pause the video right now and work on all of those. All right, this says point B will be dilated using C as the center dilation with scale factor of 4. How far should point B from point C, or how far should point B be from point C so that it lands in the hole? Well, think about this. We need this to be a scale factor of 4. So how much, if we took 10 feet and we split it up into 4 equal pieces, how far would that be? If you thought, okay, 5 feet goes into 10 feet twice, that means half of 5 feet will go in 4 times. So it's going to be 2.5 feet. And I just kind of explained it right there. I know that 2.5 multiplied by 4, which is our scale factor, is equal to 10. All right, final round. We can dilate more than 1 point at a time. So think about if we have a bigger shape with more sides, like a square or a triangle. All right. So P, point P and point R will be dilated using C as a center of dilation with a scale factor of 3. So we need to drag point P and R so that they will dilate to the point. So scale factor of 3. Well, that means we are going to be multiplying R by 3, and that distance is 2.6. Well, 2.6 times 3, not quite sure. We need to maybe use a calculator. It's 2.6 times 3 will be 7.8. And then point P is 5 away. Well, 5 times 3, 5, 10, 15. So we go to 15. And notice, originally R is almost about halfway from P. Well, then now 7.8 is almost halfway, a little bit more than halfway to 15. So here's the same image without the golf background. There's also a random point A on line segment PR. Use the sketch tool to mark precisely where A prime will be under this dilation. So try that out. Notice how we have a triangle here. All right, I'm going to take a line and I'm going to connect P and R together. And that would be our scaled version of our triangle. Now, point A, notice how C, R, and R are all in a line. And C, P, and P are all in a line. So that means that C, A, and our new A should also be in a line. And our new point for A should be right here. So notice how everything, when we scale it, goes away from this center point P at the same distance compared to where it started at. All right, so for this one, we do not have worksheets with everything, but notice how we have a scale factor of 2. So C, J, and J, the pre-image J is halfway between C and J at a scale factor of 2. So it is 2 times as far away from our original. The same thing will go for A and A prime. If we measured these 2 line segments, they would be the same. And since there's 2 line segments, well, then we know we have a scale factor of 2. So use this image and the dilations we drew to answer question 4 on our worksheet. Oh, well, we don't have a worksheet again. But notice as we continually go further away, our shape is staying similar, the same. It's just getting bigger as we go further away or smaller as we get closer to point C. So this is our last. All right. Ichiro dilated triangle ABF. So ABF. So this smaller triangle with a scale factor of 2. Precisely explain the steps for dilating point F using the same center and a scale factor of 6. Well, notice that we have 1 and 2 to get to D. And if we wanted to go, and that's 2, all right? So we're scale factor of 2. If we want to be at a scale factor of 6, well, there's 1, 2. What do? We continue 3, 4, 5, 6, and be somewhere way out here. So what am I doing? Explain what you think we are doing. You may pause right now and then come back when you are done typing. Okay, here's your cool down. I won't be going over this in the video. When we come back, then we will go over this question together.